Now we see how to get the logarithm of a given number n, and by logarithm we mean to the base 10, that is we are now dealing with common logarithms only. So for some given number which we represent as capital N, okay, the first step is to express that n in what is called as the exponent form. Okay, so we have to write the number n as the decimal number as shown here, where the integer part is a single non-zero digit, okay, and then multiplied by 10 raised to some requisite power. Okay, so basically any number can always be written in this particular exponent form. So if you take an example, suppose we want to express the number 123.4 in the exponent form. Okay, now here if we see, we need a single non-zero digit in the integer part, so therefore we will express this number as 1.234, because I have now only one digit in the integer part which is a non-zero, but then we have shifted the decimal 2 places back, so therefore to set the balance correctly we must multiply it by 100, that is 10 raised to 2. So we have written the given number in the required format. So this is called as the exponent form of the given number. Alright, now having done that, we move on and write the logarithm of the number n to the base 10 as, now here we have a number which again has some integer part that we call as characteristic, okay, and some fractional part which we call as mantissa. Now characteristic is nothing but the power of 10 in the exponent form. So that means whatever exponent form we had calculated and the power of 10 we wrote, that power is nothing but the characteristic in the logarithm of the given number. Okay, so we are through with the characteristic. Note that the characteristic can be positive, negative or 0, simply because the power of 10 can itself be positive number, negative number or 0. Whereas if you consider the mantissa, then that is always positive, and basically this mantissa consists of 4 digits, and these 4 digits are obtained with the help of log table. So this is now what we are going to study with the example. Alright, so let us go ahead and solve one example based on just finding out the log of the given number. Okay, so I request you to take out the log tables. If you don't have, you can pause the video here, and once you have the log tables ready, let us go ahead. Okay, so here is the question: using log tables, find the following. Okay, log of 543.2 to the base 10. Now if you remember, the first step was to convert the number into the exponent form. So therefore we can write 543.2 as 5.432 into 10 raised to 2. Okay, so the power of 10 in the exponent form is nothing but the characteristic. Okay, so the value of log will be 2 point something, and we have to now fill in what is there in the mantissa part. Okay, the characteristic is 2. Now to see the mantissa, what do? Is we remove the decimal place, that is we remove the decimal point in the original number and write down the 4 digits from left to right in the same order as they appear. Okay, so we have the 4 digits 5432. Now open the log tables. What you will find is, here you have on the leftmost sides the numbers written starting from 10, 11, 12, and they will go up to 99. Then you have 2 sections. In the first section you have the columns starting as 0, 1, 2, 3 and so on up to 9, and there is another section later. There also you have the columns starting but from with 1 now, so from 1, 2, 3 and they go up to 9. These are called as mean differences. Okay, the last set of columns is called as mean differences. Now what you have to do is, from the 4 numbers obtained, that is 4 digits, that is 5432, you go to the row indicating the first two digits. So that means here in our case we have 54. Okay, so in the log tables we go to that row which has 54 in the first column, very first column. Okay, then we see the third digit, that is 3 in our case. So we go to the column of 3 in the first section. Okay, and of course in the row of 54 only. Now at this point you will notice 4 digits written. Okay, so in the row of 54 and in the column of 3. Okay, I give you a few seconds to locate it yourself. Find out what is the set of 4 digits given there. You will find out that the digits are 7348. Okay, I'm just writing here also for your convenience. Okay, now what we have to do is now go to the last digit, that is in our case it is 2. Now this is the column in the last section, that is in the section of mean differences. So under the mean differences go to the column of 2 and of course in the same row, that is a row of 54 only. Now here you will find some number written, either it's a 1 digit number or 2 digit number. So in the row of 54 under the mean difference column of 2 you will find that the mean difference specified there is 2. Okay, so what do we do is we add the 2 to the previously obtained 4 digits. So that means 7348 plus 2 gives us 7350. This is our mantissa. Okay, so therefore our mantissa part is 7, 3, 5 and 0. So in other words, we have obtained the log of 543.2 to the base 10 as 2.7350 with the help of log tables. Alright, so that is a way to find the logs. Let us practice the remaining two sums also. Now in the next sum we have to find the log of 0.2987 to the base 10. So once again, first of all we write the number in the exponent form, and that is 2.987. Now here since we shifted to right, we'll have to multiply by 10 raised to minus 1. Okay, now whenever we have the characteristic as minus 1, we don't write it as minus 1 point, but we write it as bar 1 point and then we write the mantissa. This is because if we write the minus 1 and then we write some mantissa, then it would mean that the entire number is negative, isn't it? But we saw that the mantissa part has to be a positive number only. So therefore, to avoid the confusion and to indicate that it is only the characteristic part which is negative, instead of writing that characteristic by putting the minus sign as usual, we write that by putting a bar on top of it. See, apart from this there is no difference. This 1 is negative 1 only, but the mantissa part is not negative. That is why we are using the bar convention. Okay, alright. Now to find the mantissa, once again if you remember, we have to remove the decimal place or a decimal point and just consider the first 4 digits from the left side as they appear. So we have 2987. Now once again refer to your log tables, go to the row of 29 and the column of 8. You will see that we have the digits 4742 mentioned there. To that we have to add the mean differences mentioned in the column of 7. So in the row of 29 under the mean difference column of 7 you will find that the value given is 10, and hence on adding 4742 and 10 we get 4752. So that is our mantissa, and hence we get log of 0.2987 as bar 1.4752. Alright. Okay, and now lastly let us proceed to the last example, that is taking the log of 3.42615. Now here the number is already in the exponent form, in the sense that we have a single non-zero digit in the integer part and we don't have anything else, so that means it is 10 raised to 0, isn't it? Because it's getting multiplied with 1 itself. So therefore the characteristic will be 0 point. Now when we remove the decimal place or decimal point, we get 342615. You see, we get 6 digits, but log tables need only first 4. Okay, so what do we do is we skip the last 2, and of course if there is a need of rounding off, then we round off, but here since we have 1 as a 5th digit, we won't be rounding off 6, which comes on the 4th place. Okay, so in the log table we will be referring to the mantissa part for 3426 only. Alright, so 3426 means we have to go to the row of 34. Okay, look at the log table and see, in the row of 34 under column 2 we have the value 5340, and then we have to go to the mean difference column of 6. So in the row 34 under the mean difference 6, you will notice that the value written is 8. So therefore on adding we get 5348. So therefore the mantissa is 5348, and hence the log of the given number is 0.5348. Okay, so this is how we find out the log of any number to the base 10 with the help of log tables.